students, in this video we will learn the writing of equilibrium constant expression. यानी हम किस तरह से equilibrium constant expression लिखेंगे. ठीक है students? So we will learn this concept with the help of some examples. The first question which is given is a reaction which occurs during lightning storm. We will see what reaction occurs during lightning storm, students. We have diatomic molecule of oxygen 3O2. During lightning storm, this molecule is converted into diatomic oxygen is converted into ozone. We know very well what is ozone, a triatomic molecule of oxygen, ozone. We are asked to write equilibrium constant expression for this reaction. हम इस reaction का equilibrium constant expression किस तरह से लिखेंगे? Equilibrium constant expression means we will ask to write the value of Kc, since this is a reversible reaction. So value of Kc will for this reaction is, we know very well what is Kc. Kc is the ratio between the product of the molar concentration of product to the product of the molar concentration of reactants. Right students? So here what is the product? Ozone is a product. Right students? While oxygen is reactant. This is product while oxygen is reactant. So Kc is equal to O3. How many moles of O3 are given? The number of moles of ozone changes to coefficient of the balance equation changes to power. How many moles of ozone are given? Since there are 2 moles, so we write O3 raised to the power 2. Right students? Over oxygen, which is the reactant. How many moles of oxygen are given in the balance equation? Since there are 3 moles, so number of moles or the coefficient of balance equation changes to power. We write here 3. So Kc for this reaction is O3 raised to the power 2 over O2 raised to the power 3. I hope Kc for this reaction is clear to you, students. Now students, we will see what next reaction is given to us. See the next reaction. In the next reaction, we are asked to write the equilibrium constant expression for this reaction. That is, this is the second reaction, students. What is reaction? 4 moles of HCl reacts with oxygen in a reversible reaction. Right students? And we get 2 moles of water as well as 2 moles of chlorine. We are asked to write equilibrium constant expression, that is the value of Kc. Let's start, students. How can we write the value of Kc? As we know what is Kc. Kc is the ratio between the product of the molar concentration of product to the product of the molar concentration of reactants. Right students? And while writing the value of Kc, the number of moles or the coefficient of the balance equation changes to power. So how can we write the Kc for this reaction? Right students, the Kc for this reaction can be written as, first of all we will see what are the products in this reaction. Water and chlorine, these are the products of the reaction. Right students? And what are the reactants? HCl and oxygen, they are reactants. So Kc is equal to product of the molar concentration of product divided by the product of the molar concentration of reactants. So we write Kc like H2O. How many moles of water are given? 2. So 2 is written in the form of power. Right students? Into chlorine. 2 moles of chlorine are given. So raised to the power 2 divided by, what are reactants in this equation? HCl and oxygen. So we write here HCl. How many moles of HCl are given? 4. Similarly, oxygen. So this is the equilibrium constant expression, that is Kc for this reaction. I hope Kc for this reaction is clear to you, students. Now students, we will see the next reaction which is given. The next reaction is, we are given reaction number 3, that is CH3 COOH plus ethanol, this is acetic acid, ethanol C2H5OH in a reversible reaction. in a reversible reaction, right students, will form ester as well as water, ethyl acetate, that is CH3 COO C2H5, ethyl acetate plus water. This reaction is given students, right students, and we are asked to write equilibrium constant expression for this reaction. It means we are asked to write the value of Kc for this reaction. Now students, we will write the value of Kc for this reaction. As we know, what is Kc? Yes, Kc is the ratio between the product of the molar concentration of product to the product of the molar concentration of reactants. Dear students, identify products in this reaction. This is ethyl acetate, which is ester, as well as water. These are products, right students? Products are written as numerator. While what are the reactants? Acetic acid and ethanol, these are reactants, and reactants are usually written as denominator. So we will write the value of Kc for this reaction, right students? So Kc will be equal to, we write here, ethyl acetate CH3 COO C2H5, right students, into water H2O over molar concentration of acetic acid CH3 COOH into ethanol C2H5OH, right students? So here this is the value of equilibrium constant expression, that is Kc, for this reaction. I hope this is clear students. Now students, we will see the next reaction which is given. In the next reaction we are given 2HF, 2 moles of hydrogen fluoride decomposes, right students, in a reversible reaction, decomposes to give hydrogen gas as well as fluorine gas. We are asked to write the value of Kc for this reaction, right students? So let's start writing the value of Kc for this reaction. Kc of this reaction, Kc is equal to product of the molar concentration of product to the product of the molar concentration of reactants. It means product should be written as numerator while reactants are written as denominator, and the coefficient of a balance equation changes to power. So what products are here students in this reaction? Hydrogen and fluorine, both are products, so products should be written as numerator. Hydrogen 1 mole, ठीक है, 1 नहीं हम लिखते. Fluorine, since we also have 1 mole of fluorine. We also have 1 mole of fluorine. And how many moles of hydrogen fluorides are given? 2 moles. We have 2 moles. So 2 should be written as power. So this is the value of Kc for this reaction, that is the decomposition of hydrogen fluoride. I hope this is clear to you students. Now we will see the next reaction which is given. Next reaction is this is nitrogen peroxide or nitrogen dioxide, right students? In a reversible reaction, nitrogen dioxide, 2 moles of nitrogen dioxide converted into dinitrogen tetroxide, that is N2O4, and we are asked to write the value of Kc for this reaction. Now students, we will write the value of Kc for this reaction. That will be Kc is equal to the product of the molar concentration of product to the product of the molar concentration of reactants. It means product should be written as numerator while reactants should be written as denominator. So what product is given here? Dinitrogen tetroxide, N2O4, right students? And what is the reactant in this reaction? Nitrogen peroxide is the reactant. How many moles are given? 2 moles are given, so 2 should be written in the form of power. So this is the value of Kc for this reaction. Now students, we will see another example, right students, to understand the concept. The next reaction which is given is the reaction of carbon monoxide with hydrogen. Carbon monoxide with hydrogen, right students? In a reversible reaction, we will get methane plus water, CH4 plus water vapors. Now write the value of Kc for this reaction. So Kc for this reaction is equal to, product should be written as numerator, while reactants they should be written as denominator, and the coefficient of balance equation changes to power. So what products are given here? CH4, right students, and water. These are the products for this reaction. And what reactants are given? Reactants are, we have carbon monoxide, 1 mole is given, right students, 1 हम नहीं लिखते. And how many moles of hydrogen are given? 3 moles. So 3 should be written in the form of power. Right students, I hope you understand how to write the coefficient of, how to write the equilibrium constant expression for the given reaction as well as the value of Kc.